Okay, independent events and tree diagrams, page 131, section 9.3. Doing a grade B question, then launching straight into grade A and up to A star in this section. So, reading from page 131, it says, events are independent if the outcome of one of the events does not affect the outcome of the other. Sounds sensible, doesn't it? If two events are independent, then the probability they will both happen is found by multiplying their individual probabilities together. We'll see that in a minute. So this is question 2 on page 133. It says, complete the tree diagram and then use the tree diagram to find the probabilities of all the possible outcomes. A bag has 10 balls, 3 with the letter A on them and 7 with the letter B. One ball is taken out at random and then it's replaced, and then a second ball is taken out at random. Basically, I've got to prepare the tree diagram and finish it off. Right, what we got then? We got, let's just go through this question. So we got the chance of getting an A, probability of getting an A with the first ball is going to be 3 out of 10. There's 10 balls in total. 3 have got an A on them. 7 have got a B on them. Sorry, there's the A. Right, if the chance of picking up ball B is 7 out of 10, then 7 over 10 it is. Okay, so then put it all back in, shake up the bag again. The probability of getting a second A will be 3 out of 10. In the same way, the second B will be 7 over 10, and also down here 7 over 10. So that's the tree diagram done. And if we have a look here, because these events are independent, the probability of getting a double A, so probability of AA would be 3/10 followed by 3/10, which is 9/100. We'll do the same here. Probability of getting an A followed by B is going to be 3/10 followed by 7/10. Well, that's 21 over 100. Next one, probability of getting a B followed by an A, that's 7/10 followed by 3/10. Again, 21 over 100. And the probability of getting a letter B followed by a letter B is going to be 7/10 followed by another 7/10, 49 over 100. And that's all there is to it. So this question is grade B rated. What it does is give you an opportunity to play with independent events, and please note the word replacement. Later on we'll talk about without replacement, where the probability becomes conditional. Right, that's just as a starter, and that's grade B. That's dead easy. Next question. Now, the probability that Mike takes a bus, I believe this is question 3 on page 133. The probability that Mike takes a bus to work is 0.8, and the days are independent from each other. So in other words, what he does on Monday or Tuesday or Wednesday won't affect what happens in future days. Totally independent. It says work out the probability that Mike takes the bus on Monday and Tuesday. Okay, so the probability of getting the bus on Monday and Tuesday, don't have to write this, but it's nice because they're independent events. It's 0.8 followed by 0.8. 8 takes us 64. 0.64. Okay, so the probability that Mike gets a bus on the Monday is 0.8, and on the Tuesday is 0.8. We want both events to occur one after the other, therefore you multiply. 0.64. This is question 4, a bit more complicated, and it's grade A rated. Lorraine has a packet of crisps and fruit juice for her lunch every day. The probability that she has roast chicken flavoured crisps is 0.2. So here we go, just underline that. And the probability that she takes orange juice is 0.4. What is the probability that she has roast chicken crisps and orange juice? In other words, crisps and juice. Well, the probability of crisps and juice, well, probability of crisps is 0.2. And, excuse me, so we multiply, and juice, 0.4. Well, 2 4s are 8, 0.08. That's part A done. Now part B is a little more complicated, so let's study it carefully. What is the probability that she does not have crisps and does not have juice? Okay, so no crisps and no juice. Alright, so let's take a look. Probability of no crisps and no juice. Again, in the exam you don't have to write that. Just because I'm on the vid now, I want you to see what I'm doing. Okay, the probability of having crisps is 0.2. Therefore, the probability of having crisps is 0.2. Therefore, the probability of not having crisps will be 1. Take away 0.2, which is 0.8. That is the probability that Lorraine does not take crisps to school. Presume it's school. Now, again, likewise with the orange juice, the probability that she has orange juice will be 0.4. Therefore, the probability that she doesn't take orange juice will be 1 minus 0.4. Remember, the probability of all independent events add up to 1. So that gives us 0.6. Back to the question. What is the probability that she does not take roast chicken, that one, and crisps, roast chicken crisps, and does not take orange juice? So it's 0.8 times 0.6. That's not crisps and not juice. Well, 6/8 of 48, 0.48 is the probability there. And you're looking at grade A.